So what I want to talk about now is what's called conditional probability. And you'll see it like this. It's this kind of notation. And what it says is this: the probability of B given A. So what's going on here? Well, we're doing something that we've sort of not considered doing at all. We're going to take our sample space and shrink it. So we shrink sample space down to event A. This is the idea. And then once we've shrunk it down to event A, we ask, what's the probability of B occurring? What's the probability that event B occurs? Well, let me give you an example of how this works. Let's go back to our cars example. So this would be a blue Toyota, blue Ford, green Mercedes, green Mercedes. So we might say something like this. What's the probability of the event you get a Toyota given we reduce our sample space to just blue cars? So what this says is this. First off, focus on this. Reduce our sample space to blue cars. And then once we've done that, we ask, what's the probability of getting a Toyota amongst the blue cars? So for this, what this means, probability of Toyota, given we've reduced our sample space to just the blue cars. Well, there were only 3 blue cars, a couple Toyotas and a Ford. And of the couple Toyotas and a Ford, there's only a couple Toyotas. That means there was only 2. And well, that's your answer, 2/3. Another way you could think about this, again, we could use Venn diagrams. So for example, let's go back to this. There's A, there's B. We have 4 elements in A. One of those elements overlaps with B. There's 3 elements in B. Again, one of them overlaps with A. We have 3 on the outside. So we might ask the question, what's the probability of event B given we reduce our sample space to event A? So basically what this means is we're going to take our world and we're going to shrink it down. So everything's going to go away except event A. Now, this looks like B's disappeared, but not really. Remember, B overlaps with A. So technically B this is what's left of B. It happens to overlap with A. So we wipe out everything except the domain of A here. And so we ask this question. So now we've reduced things to event A. Now, how many elements are in event A? There's only 4. Of those 4 elements, how many of those were also in event B? Oh, only 1. And so the probability of B, given that we've reduced things down to A, well, there you go. Another way of thinking about it, it's the probability of B occurring given that A's already happened. Once A happens and none of this other stuff happens, we get rid of all that other stuff. We just focus on a world where A has occurred. And then we ask, okay, now that A has occurred, how much room is there still for B? And so that's what we've got. So that's the idea of conditional probability. If you have any questions, let me know.